Hey AP Calculus students, welcome back. Today we're looking at lengths of curves. So the good news is this one's pretty straightforward. It's not too bad. So we're trying to find the arc lengths for any of our functions. So in order for us to do that, notice there's two different ones, but we could just say the same thing. It's the integral from a to b, the start to the end, of square root of 1 plus the derivative of y with respect to x squared dx for any function of x. And then it's the same thing for the y, it's just that this one is the derivative of x with respect to y dy, but the same exact formula. All right, so if we're looking for this, the length of this curve, y equals 4 square root 2 over 3x to the 3 halves minus 1 for x is between 0 and 1. All we have to do is set up our integral from 0 to 1, and then we're doing square root of 1 plus the derivative of our function with respect to x. So the derivative of this, we should write this down, derivative of y with respect to x is going to be 4 square root 2 over 3, and then the derivative is going to be 3 halves x to the 1 half, and then the 1 is going to derive out. Right, so then cancel a bunch of things, so you get 2 square root 2 x to the 1 half, or should we just say 2 square root 2 x? Yeah, that works. Okay, so dy dx. So it's going to be 2 square root 2x squared dx. Now let's simplify this stuff a little bit more. So we get from 0 to 1. 2 squared is 4. And then the square and the square root here cancel, so we get times 2x dx. So we get 1 plus 8x square root dx. And I guess we can just use our, let's just use our calculators. Might as well. Okay, so let's go ahead and do our math 9 from 0 to 1 of the square root 1 plus 8x dx, and that's 2.1116, 2.167. It doesn't give our units, so units. Okay, on to the next one. It's asking us find the length of y equals 1/3 x between 8, -2 and 8, 2. So it's noting here it's a vertical tangent. So let's find our graph. Let's delete these, and we're graphing x to the 1/3. X to the 1/3. Okay, so do notice that at 0 we'd have a vertical tangent, which is going to mess up our calculations a little bit because we're trying to go from 8, -2 and 8, 2. So if we're chopping this up this way, right, if we're deriving with respect to x, it looks like this. So if we're deriving with respect to x, we're going to hit a road bump right in here where our tangent is vertical. So what they're saying to do is let's do it in terms of y then. So we don't have the vertical tangent, or we don't have a tangent in there where we're going to get messed up if we chop it up this way. Okay, so let's do it with respect to y this time. So remember when we do, sorry, this shouldn't be 1/3 x, it should be x to the 1/3. When we chop this up vertically, we need to make sure our integral goes from our y values. So this is from -2 to +2. And we also have to solve this for y. So y equals, this would be the cube root of x. So y cubed equals x. So we're going to do y cubed dy. Oh, sorry. We're finding the length of the curve. So we do want to know that's y cubed. So x equals y cubed. So we need to do our thing, right? We need to say square root of 1, where is it? 1 plus dy dx squared, or dx dy squared, 1 plus dx dy squared dy. Alright, so the derivative then of our x with respect to y would be 3y squared. So 1 plus 3y squared squared. And we're doing the integral from -2 to 2. And let's just use our calculator again. So we're going to do math 9 from -2 to 2. And we're doing square root 1 plus parentheses 3 x squared. X squared squared. And we could have just said 9x to the 4th. That would just been easier. But okay, it's calculating, and we get 17.261. Okay, so not too bad. Just be very careful if we have some kind of vertical tangent. If we're chopping it up by x, we might want to reconsider and chop it up by y, because it may give you the right answer in your calculator if you set it up in terms of x, but it may not. So just be very careful. Okay, and then the last one, another strange case. So we need to figure out here, right, what this looks like. X squared minus 4 absolute value x minus x. So x squared minus 4 absolute value x and then minus x. And we're doing this from -4 to 4. So notice here that we have this point right there at 0, 0, where it's not differentiable because we have a corner or a cusp. So what we're going to do is we're going to do this in 2 parts, and we're lucky that it's at 0, so it's easy to split up our integral starting and end. So we're just going to do this in 2 parts. So we're going to do one from 0, well actually from -4 to 0. And we're going to do from 0 to 4. And then we're going to set this up as the derivative. I don't know what the derivative of this absolute value is going to be. 4 absolute value of x. the absolute value of x is going to be positive when it's negative and negative when it's positive. It's actually harder than it seems, but in the book it's saying that if we do x squared minus 4 absolute value of x minus x, that's going to be equal to x squared plus 3x when x is greater than 0, and then x squared minus 5x when x is less than 0. Okay, so that kind of helps us. So when it's greater than 0, that would be this part. We're going to use the derivative of x squared plus 3x is 2x plus 3. So 2x plus 3 squared. And then if we know it looks like that, then the derivative of x squared minus 5x is going to be 2x minus 5. And then we find the two parts separately using our calculators. So if we're doing math 9 from 0 or negative 4 to 0 of the square root of 1 minus parentheses 2x minus 5 squared dx, and then we add the second part, which is the integral from 0 to 4 square root 1, oops, this should be a plus, square root of 1 plus parentheses 2x plus 3 squared dx. Then we should come out with the correct answer, but we didn't. How come? Did I forget something here? I forgot this square, I think. Anyways, when we do this correctly, not like I did it, we should end up with 19.56. I'm pretty sure I forgot to square the second part. No, I did that correctly. 1 plus 0 to negative 4. I think I got my integrals mixed up. Okay, but anyways, yeah, I think this one should have been x is less than 0. Or maybe I wrote it wrong. Oh, yeah, so this is when x is less than 0, and this is when x is greater than 0 from the book, sorry. So these should be switched. This one should be from 0 to 4, and the other one should be from negative 4 to 0, and that's why I got it wrong. And I think that's it. So I'm not sure how much of this arc length stuff you're going to be doing, or the length of the curves stuff you're going to be doing on your end of course exam. I wouldn't be super worried about it. And if you do, I'm not sure it'll be the harder cases. It might be just the easier ones. So it's good practice. We're kind of wrapping up. There's only a few more sections left. So keep hanging in there, keep working hard, and I'm sure we'll be ready for our test soon. All right, good job.